this proof here has you really understanding notation. It's not hard at all, but you really got to understand notation. So first things first, don't forget, the three options that we have. This is going to be really, really helpful for some of you. So maybe you can already see which ones we can exit out. Maybe you can't, but whatever. Let's go ahead and go to what we have. So we have line XW. So that means this line here is congruent to line XY. So we actually have like a tick mark, a tick mark. So XW is equal to XY. Okay, notice how it has the line on top. So that means we're talking about a side. Okay, so if there's a line on top, we're talking about a side. If it's an angle in the front like that, then we're talking about an angle, right? Kind of obvious, but for those of you that need it. All right, so then we have that there. Let's go ahead to the next part. So line HA, something about this line. And then you have this notation here. Now, so this is not new notation, okay? If this is new notation for you, you need to go back and review. This here means perpendicular, okay? Now, perpendicular basically just tells you like one piece of information, which is where the two lines intersect, they intersect at 90 degrees. So technically, I can go ahead and do 90 degrees there. I mean, or you could do it on the other side. It doesn't really matter because those are that's a straight line anyways, so that means it's supplementary. Okay, so we have that there. And then we have another set of right angles based off of this other one, so KB, so we're talking about like this 90 and then that 90, okay? And so now we used up all the information there, okay? We have a pair of sides are congruent. We have a bunch of 90-degree angles. Let's just slow it down and let's actually look at what we're trying to prove. So, because I really want to redraw it since there's just so much stuff going on there. Okay, so we're talking about triangle HWA. So, HWA. So, we're talking about, let me change color. We're talking about HWA. So, it's that little one right there. So, we have H, we have W, and we have A. Because it's perpendicular, I know I have a 90-degree there. Okay, and then we have the other triangle, which is going to be KYB. So KYB. So then it's basically like the other little triangle there. So we have KYB, and then because of the perpendicular, we have the little right angle there. So if you notice already, we have an A. So we technically have like an A right here. This one could potentially be the A, but we need the sides. Now, the only thing that we have is we have two congruent sides, but let's really be very careful here because I'm going to strip everything and I want to show you. The sides that they're talking about is WX. So it's talking about the big side. So it's technically this side here with this missing piece there. Okay, so you need to be careful. What this means is we don't know if this side is equal to this side because it's not the same length. So just be very careful with, moving over the tick marks really, really fast. Okay, so we have nothing about sides basically that deal with these two triangles, okay? This big XYW triangle, yeah, we do have sides, but over here we have nothing. So what that means is no SAS, no SSS. So we have to do AA somehow. And this is where this problem becomes a little bit hard. So the trick that we've been using is, one angle being the same in both triangles. But if you notice here, angle X is nowhere to be found in these two triangles. So we can't do that trick. Okay. And so what basically you're going to have to, and this is why proofs I think sometimes are really hard, is because it comes out of nowhere. You just have to sit there and really think about it. And so this is what I'm going to do actually to try and see if you can figure it out by yourself. I'm going to draw the big triangle. So X here, W here, Y here. And I'm going to go ahead and draw this tick mark here. And really let you think about it. How is that going to help me, okay? What I'm going to do is I'm going to highlight this angle is equal to this angle. And it's also the same as that angle. So if you notice, it's like taking a little piece of that big triangle. And then we have this triangle here, which is that one, and it's also that one. Okay. And so hopefully you're you're thinking about it, you're trying, but this is actually, so we have triangle XYW is actually an isosceles by definition because it has two congruent sides. And so by definition, an isosceles, it has two congruent sides. It also has two congruent angles. So what that means is that these two angles are congruent because they come from an isosceles triangle, right? So that right there is super important. So we can say angle W is congruent to angle Y by definition of an isosceles. And you see this here is where if we were be doing a formal proof, we would already have like 2-3 lines, above this where we say it's an isosceles. By definition, it has two congruent angles. And then the two angles are these two right here. Okay. All right. So we have that there. And let's basically just really think about what we did. Okay. We were able to show two angles inside the two different triangles are congruent because they come from a different triangle, the bigger one. It gets this complicated, okay? So that's why these proofs are so hard. But technically thinking about these two, we actually have already 1A, which is really nice, okay? And then thinking about the fact of, perpendicular lines, we actually already have another A, which is going to be the right angles, right? So we're pretty much already done. We already showed AA. All we have to do is really just write it down. So what I'm going to go ahead and do is I'm going to do that last other statement. I'm going to do the angle A one. Oh, sorry, the 90-degree one. So let's go ahead and write it. I'm going to say angle HAW is congruent to angle KBY. And we say, we can say a lot of things, right? They're both equal to 90 degrees or they're both right angles, right? So whatever you want, really. So both equal to 90 degrees. You can say right angle, whatever, okay? But the whole point is that this is also the A. So here we go. We have AA already. And so then really just the last thing I can go ahead and do is just write my similarity statement and say it's by AA, okay? And so let me just remember what the HWA, okay? So HWA and KBY. Okay, I was trying to see if I had made a mistake or anything. So HWA, all right. So then we can say triangle HWA is similar to triangle KYB. So triangle KYB by AA similarity, okay? This is a very good example of, how things can get really hard really fast just because you have to use stuff from before, which in this case, it was isosceles triangles, and we can throw a lot of different things at you. We can throw, parallel lines. We can throw angle bisectors. We can throw amplitude. We can throw just so many different things that you need to know, which is why I think a lot of times people have a really hard time with proofs. Okay.